Hello, this is Professor Esther Pearson and welcome to the statistics class. We will begin with Chapter 1, Introduction to Statistics. In our Introduction to Statistics, let's take a look at some definitions. Statistics is the science of gathering, describing, and then analyzing data. Statistics is the numerical description of sample data. Let's continue on with some additional definitions. Next, data. Data is information, in particular, information prepared for a study, a statistics study. Next, population. A population is a particular group of interest. And parameter. A parameter is a numerical description of a particular population characteristic. And lastly, census. When data is collected from every member of the population, that is known as taking a census. As we continue on taking a look at definitions, next we have sample. A sample is a subset of the population from which data is collected. In other words, a smaller group taken from the population. A sample statistic is a numerical description of a particular sample characteristic. Let's continue on taking a look at some examples. A population is the whole group. The sample would be part of the group. The population would be group I want to know about. The sample would be the group I do know about. The population would consist of characteristics which are called parameters. A sample would consist of characteristics which are called statistics. Parameters are generally unknown in a population. Statistics are always known in a sample. In a population, the parameters are fixed. In a sample, statistics change with the sample. Now let's identify the population and the sample. In a survey, 359 college students were asked if they had tried vanilla Coke. 83 said yes. The population would be all of the college students. The sample would be the 359 college students in a survey. Let's take a look at another. A survey of 1,125 households in the U.S. found that 65% subscribe to digital cable. The population would be all U.S. households. The sample would be 1,125 households. Now let's take a look at, is the numerical value a parameter or a statistics? And we will do that taking into mind what we've learned previously about a parameter and a statistic. The average grade on Test 1 in Miss Shirley's statistics class is an 87. That would be a parameter. The average math score for all high school graduates on the SAT was 519. That would also be a parameter. In a survey of 135 college students, 52% of them said they plan to attend graduate school. That would be a statistic. So we see a parameter is in regards to a population, and a statistic is in regards to a sample. Let's continue on looking at some other scenarios. The principal of a large K-12 school is considering adopting a dress code for the upcoming school year. Before going to the school board, he wants to know the percentage of parents who would favor a dress code. He randomly chooses 15 families from each grade to interview. Out of the 195 families surveyed, 76% favor a dress code. Identify the population and sample. The population would be all families of the students at the school. The sample would be the 195 families that participated in the survey. Does the value 76% represent a parameter or a statistic? It would represent a statistic because it's taking into consideration a sample. Next, let's take a look at the branches of statistics. First, we have descriptive statistics, in which we gather, sort, summarize, and display the data, just the facts. Then we have inferential statistics, which uses descriptive statistics to estimate population parameters, an educated guess about the population based on the facts. Thus, we use the word inferential, or to infer about a statistic based on the population, or to infer about a sample based on the population. Now let's take a look at how we can identify the descriptive statistic and what inferences can be made. In a survey of 100 students, 83.2% of students are happy with the food in the cafeteria. That would be descriptive statistics, whereas 83.2% of the 100 students surveyed are happy with the food in the cafeteria. Possible inferences we could make from that 83.2% of all students are happy with the food in the cafeteria. We took a survey with a sample of 100 students, and based on our findings from that sample, we inferred a characteristic about the entire population. In other words, we inferred a characteristic about all students based on information from the sample of 100 students. Next, let's look at qualitative versus quantitative data. So qualitative and quantitative, what are each one of those terms? Well, qualitative indicates descriptions and labels. Quantitative indicates counts and measurements. Now let's take a look at how we can classify data as qualitative or quantitative. The weights of members of the football team. That would be quantitative data, or numbers or measurements. The flavors of Ben & Jerry's ice cream. That would be qualitative data, types or names of data. The jersey numbers of a women's basketball team. That would also be qualitative data because the jersey numbers are used simply to identify the woman on the basketball team. What about student ID numbers? That would also be qualitative data because the student ID numbers are simply meant to identify a particular student. Next, let's take a look at continuous versus discrete data. So as we look at qualitative and quantitative data, quantitative data can be discrete, which are usually counts of things. Quantitative data can also be continuous, which are usually measurements. Now let's see how we can classify data as being discrete or continuous. The temperature in Fahrenheit of cities in North Mississippi. That would be continuous data, or a range of possible temperatures. The number of rooms in a house. That would be discrete because a house has a specific number of rooms. The number of peanuts in a jar. That would also be discrete because the jar would contain a specific number of peanuts. The height of a door in inches. That would be continuous because the height of a door might vary based on one door or another. Next, let's take a look at levels of measurement. First, qualitative and quantitative. Qualitative data is also known as nominal, or data that has names like red, blue, like Ford, Chevrolet, named data. Then there's also ordinal data that is part of qualitative data, data that is in a specific order, first, second, third, fourth. In terms of quantitative data, we have intervals where 0 is simply a placeholder, not representing a value. And then we have ratios in quantitative data, wherein 0 means the absence of something. So that's our two types of data, qualitative and quantitative, and the levels of measurement that are within them. Now let's take a look at determining the level of a measurement. Today's high temperature in Fahrenheit for varying cities across the U.S. That would be quantitative, meaning it's numbers, and it would be in intervals. The colors contained in a box of crayons. That would be qualitative and nominal or named data, red, blue, green, various names of data. The boiling point in kelvins for varying chemical compounds. That would also be quantitative data in terms of the data would be in a ratio form. Then the individual page numbers at the bottom of each page in the statistics book. That would be quantitative data, and it's ordered data, page 1, page 2, page 3. Next, let's take a look at some questions and how those questions can be answered by defining our population parameters or variables, and then we would collect data. Then we would calculate a statistics, and remember a statistics is a sample, and then we can estimate a parameter. So we have a research question. We define the population of interest that we want to take a look at. Next, we collect data from that population, Then we take a sample from that population and calculate a statistic. And then based on that statistic, we can estimate something about the population, or we can estimate the parameter. And this is a cycle. It continues to go on and on. Once one question is answered, it can lead to follow-up questions, and the cycle continues. Next, let's take a look at the types of studies for statistics. We can have an observational study, and that's a study where the researcher observes data that already exists. So the observer simply views and records. We can also have a type of study called an experiment, and that's where the researcher seeks to create data to identify cause and effect relationship. Something happens that causes an effect. So those two things have a relationship. And that's an experiment where you manipulate or change something. The difference between an observation and an experiment is an observation, you don't create data. You just look at the data that already exists, view it, and record what you view. Whereas in an experiment, you manipulate the data in order to look for causes and effect relationships. Now let's take a look and see if we can identify an observational study from an experimental study. A medical researcher wants to examine the effects of exercise on vascular health. A key word we see there is effects. That would be an experiment, because the researcher would be manipulating or changing something within exercise to see how it would affect cardiovascular health. How about this one? A recording company is interested in knowing the percentage of teenagers that download music off the internet. That would be an observational study, wherein the recording company would just view the information that was already created and make observations about it. View and record what you see. And here's one last one. A chain of grocery stores want to know how much the average family spends on produce each month. That would be an observational study, because the grocery store wouldn't be changing anything. They would just be observing how much was spent and recording that information. Let's take a look at observational studies. An observational study asks, how will the data be gathered? What is very important is it's essential that a representative sample is chosen out of the population. And that simply means that the sample that you choose from the population should represent the population or have like characteristics. The sample should be similar to the population. A good sampling frame is the first step to choosing a representative sample. The sampling frame is a list of members of the population, and it is from that list that you choose a sample. Now let's take a look at sampling techniques. The first technique we have is a census. The second we have is a random sample. Then we have a stratified sample, a cluster sample, a systematic sample, and a convenience sample. Let's take a look at each one of those in more detail. First, we take a look at a census. A census includes every member of the population. So you're taking a population, but you're selecting as a sample every single member of the population, just as you see in this picture, with members and a red circle drawn around every single member. So that's known as a census sample. Next, we have a random sample, and that's where every member has an equal chance of being selected. So you have a population, and then you just randomly, by chance, select members from that population, each member having an equal chance of being selected. Next, we have a stratified sample, and that's where the population is divided into subgroups called strata, and the same number of subjects are chosen from each strata. In this example, we have freshman students, junior students, sophomore students, and senior students, and those are called our strata. And then we select one member out of each strata. And so we see the population is divided into subgroups called strata, and the same number of subjects are chosen from each strata. In this case, one subject is chosen from each of the strata. Next, we have cluster samples, and that's where the population is divided into subgroups, but those subgroups are called clusters. And those clusters are similar to the population, and whole clusters are chosen at random. So in this example, we have class 1, class 2, class 3, class 4, and class 5. And we select as a sample an entire class. And so that would be a cluster. Next, we have a systematic sample. That's where selecting every nth member of the population. So you have the population and you determine how many members you're going to count off, and then you'll select a member. In this example, we have 1, 2, 3, 4. We select the fourth member. We count again. 1, 2, 3, 4. We select the fourth member. We count again. 1, 2, 3, 4. We select the fourth member again. So in this example, we're selecting the nth member, or we're selecting the fourth member of the population. Next, we have a convenience sample. And that's the sample is convenient for the researcher to select. In other words, the researcher doesn't do a lot of planning in order to get his or her sample. They just do whatever's convenient for them. And so that is called a convenience sample. Convenient for who? Convenient for the researcher. Now let's take this opportunity to identify the sampling method. Chosen at random, 200 rural and 200 urban persons age 65 or older were asked about their health and experience with prescription drugs. That would be a stratified sample, where we take a population, we divide it into strata, and then we select the same number of members from each strata. Next, let's take a look at this scenario. For quality assurance, every 12th engine part is selected from an assembly line and tested for durability. That would be systematic sampling, because we're selecting every 12th engine part. Lastly, a survey concerning the taste of a new soda flavor was performed at the local grocery store from 5 p.m. to 8 p.m. That would be convenience sampling, because a time frame was selected that was convenient for the researcher. There was not a lot of design or planning to this sampling method. It was just whatever was convenient for the researcher. Okay, let's continue on identifying the sampling method. How about this scenario? To determine how a particular political candidate was going to fare in an upcoming election, different counties in the state were randomly selected, and every eligible voter in the randomly selected counties was surveyed. That would be a cluster because we took the population, divided it into counties, and then selected entire counties to participate. So those counties would be called clusters. So that would be an example of the cluster sampling method. Next, to determine who will win a $1,000 shopping spree at the local mall, the owner of the mall draws a name out of a box. That would be random sampling, because each person who put his or her name in the box would have an equal opportunity of being selected. So that's known as random sampling. Next, we'll take a look at experiments. Within an experiment, you have subjects. Those can be people, animals, or things that are being studied. When we have participants, that's a term used when the subject of the study are people. People participating in an experiment are called participants. Then we have within an experiment a treatment. And a treatment characterizes an experiment. It applies to some or all subjects. Some or all of the subjects in an experiment would be given a particular treatment. Then we have a treatment group, and that's the group in which researchers apply a treatment. We also can have a control group, and that's a group identical to the treatment group, except that no treatment is applied or given to that group. And that's why it's called a control group. Let's continue on looking at experiments. There can be a single masked experiment, and that's when the subjects do not know in which group they have been placed. They don't know if they're in the experimental group or they might possibly be in the control group. Then we also have double masked experiments, and that's when neither the subject nor the people interacting with the subjects know to which group the subjects belong. So in a double masked experiment, the subjects don't know if they're in the experimental or the treatment group or the control group, and the researchers don't know either. Then we have a placebo, and that's a substance that appears identical to the actual treatment. A placebo is sometimes called a sugar pill because there's no actual active ingredient in that particular treatment. Whenever conducting research, there are ethical concerns where we have to take a look at what is right, what is wrong, what is moral, what is political, what is lawful, what is unlawful, based on the experiment or the research that's being conducted. To watch out for these ethical concerns, there's a board called the Institutional Review Board, and they're responsible for being the watchdogs over the ethical concerns of a experiment. Within an experiment, there has to be informed consent, meaning the persons participating in the experiment have to be told what they're participating in, what the experiment consists of, and then they can give their approval to participate. We also take a look at the ethical concerns, whether it's humans or animals. Both have to be taken into consideration in terms of making sure that they're treated in an ethical manner. Also, a part of ethical concerns are confidentiality. In some instances, in most instances, we want to keep the identity of the persons or the subjects participating in our research confidential so that they remain anonymous. No one knows who they are or can identify them. There are also practical concerns, such as biases. When you're conducting an experiment, you have to be aware that it's possible for a bias to be present. And a bias is simply an unfair situation. There are research biases where a researcher might be prone or prejudicial in terms of how they look at the results of the research. There's also sampling errors, and that's where it's possible to make an error when you take a sample from the population. There's also non-sampling errors, and that can consist of things such as typos or miscounts. So let's take a look at those errors. We have sampling errors and non-sampling errors. For a sampling error, it could be a dropout, and that's a participant who begins in the study but then fails to complete it. They simply drop out of the study. You can also have a poor sampling frame wherein you select the wrong subjects. There can be participant bias, and that's when there's a problem with either the participation or lack of participation of those chosen for the study. Next, let's look at non-sampling errors. And those are processing errors, or an error as simple as making a typo. There also is lying or faulty memory. When participating in a study, if the participant doesn't tell the truth or they have a faulty memory, meaning that they can't remember the information that you're asking them to, they can't recall it, then that could lead to a non-sampling error. There is also what's called non-adheres, and those are subjects who stray from the directions they are given. They simply don't follow the directions for the study. And lastly, there's confounding variables. When you think of the word confounding, think of the word confusing. So confounding variables or confusing variables, they are factors that influence the results of the study that the researcher did not or could not account for. The researcher had no idea that there was something else going on, some other factor going on in this study that would confuse the results or the conclusions of the study. Now we have something to think about, something to ponder. Consider preparing a research proposal for the following question. What percentage of 11 to 16-year-olds smoke cigarettes? We would have to ponder or think about what are some possible issues of getting informed consent, because these participants are minors, they're under the age of 18 or under the age of 21. We'd also have to think about confidentiality, keeping their identity confidential. Going to the Institutional Review Board or the IRB, they would have to take a look at our study to see if it's ethical to ask minors to smoke or find out about if they are smoking. Then we have to take a look at the fact that we're dealing with human subjects. What could go wrong? What could possibly be of detriment to those subjects? And then biases, whether they're participant biases or research biases. What things are present that might lead the conclusions in one direction or another? What might make the conclusions prejudicial? What might make the conclusions go in one direction or the other? Those are biases. These are all things we have to ponder, we have to think about when we're going to conduct research. Okay, let's take a look at some examples and we'll try to pull it all together, all that we've learned so far. A Computech is a large computer company with hundreds of thousands of customers across the country. They're interested in knowing the percentage of customers that are satisfied enough with their purchases to continue buying Computech products in the future. The company hires an independent research firm to conduct the study. The firm randomly selects 50 customers from each of the following metropolitan areas: New York, Los Angeles, and Chicago. They find that 77% of the customers surveyed are satisfied with their Computech purchases and plan to continue buying Computech products in the future. Using statistical methods, the firm estimates that between 74% and 80% of all Computech customers will continue doing business with the company. So first we need to identify who the population is. The population are all Computech customers. Then we would identify the sample. The sample is the 150 customers that were surveyed, 50 from New York, 50 from Los Angeles, and 50 from Chicago, and that would give us our sample size of 150 customers. Next, we want to identify any statistics, and we know statistics are taken from a sample. And from that we find that 77% of the customers surveyed are satisfied. And so that's how we can take a scenario and look at it and pull out key pieces of information. You will do this same technique when you have your article analysis within this statistics class. You'll read through an article, you'll identify the population, the sample, and some of the key pieces of information. Let's take a look at this same Computech scenario and pull out a few more pieces of interesting information. Identify the parameter, and we associate parameter with population. There are between 74% and 80% of all customers are satisfied. What sampling technique was used? Stratified sampling. We took the population, divided it into metropolitan areas of New York, Los Angeles, and Chicago, and then we selected the same amount of customers from each of those strata to participate in our research. Is the study biased? If so, what type of bias possibly occurred? Well, there could be sampling errors since the population of the U.S. was not represented. And what we mean by that is we only chose the metropolitan areas of New York, Los Angeles, and Chicago. To avoid sampling errors, we should have also chosen some smaller cities, such as perhaps Cleveland, Ohio, perhaps Boca Raton, Florida, perhaps Duluth, Minnesota. That way we don't have just the large metropolitan areas, but we also have some of the small rural or Midwest or Eastern cities that also buy Computech products. A few more items to consider in terms of our story of the Computech study. Consider the following phrase: the firm estimates that between 74% and 80% of all Computech customers will continue doing business with the company. Is this an example of descriptive or inferential statistics? Well, it's an example of inferential statistics because we took an entire population, chose a sample from that population, and then inferred or predicted from the sample a characteristic of the population. So that would be inferential statistics.